Gee, I'm a tree. Hey guys, welcome back. We're going to continue our coordinate geometry with determining the perpendicular bisector of a line segment. We have learned basically everything you need to know in order to do this, all the information, but you're basically just going to have to put together a bunch of different steps. So we will write out all the steps for you when we go over examples, but before we get started, let's talk to our special guest. Say hi, Domo. Domo says hi. Dom Dom. Anyway, so Domo's going to help us out, make sure that you guys understand it as well as we do. Is that okay, Domo? Yes, it is. Okay, so we're going to talk about perpendicular bisector first. What exactly that is a line that crosses the midpoint and is perpendicular to the line segment. So if I have a line segment, so I have 2 points, and we connect them, we need to get a line that goes through the middle point and also creates a right angle. So we're looking for the equation of this line. Make sense, Domo? Yes, it does. Okay, let's take a look at what exactly we need. We need 2 pieces of information. We need the slope and the midpoint. And those 2 things you should know how to do. So let's move on to an example. Find the perpendicular bisector between the points 4, 6, and 16, negative 2. Okay, so the first step. Domo, what do you think the first step is? I don't know. Okay, well, let's find the slope of between these 2 lines. Okay, so the slope is going to be equal to the difference of the y's. So we're going to do 6 minus negative 2 all over 4 minus 16. When we simplify that, we get 6 plus 2, which is 8. 4 minus 16, that's negative 12. We can simplify that. You can reduce it by 4, so you end up getting 2 and 3 here. So our slope of the original line is negative 2 over 3. Now, if we have, remember, we're looking for the line that is perpendicular. So step 2, we're going to find the slope of the perpendicular line. So I'm going to put m with a little perpendicular sign. Remember, we flip it, so I get 3 over 2, and negate, meaning we change the sign. So it's negative, it's going to become positive. And that's 1 piece of information we already need. Okay, Domo, everything okay? Yes, it is. It is so awesome, finding the perpendicular bisector. Okay, yeah, Domo, okay, whatever. Anyway, so let's take a look at the third thing we need to do. We need to find the midpoint. Okay, so the midpoint between the 2 points. So that we need, remember, to find the equation of a line, we need the slope, which we have here, and a point that line is going through. If we look at our little example, that point is going to be a midpoint. So we add the 2 x values, so 4 plus 16 is 4 plus 16 divided by 2, and then add the y values, so 6 plus negative 2 divided by 2. We end up getting 20 divided by 2 and 4 divided by 2. And that gives us a final equation of final midpoint of 10, 2. Now, we have our point, we have our slope, so step 4, we got to plug it into the equation. So, remember, y equals mx plus b. We have an x and y right here. So we plug in y is 2. The slope we know is 3 over 2. And the x value in this case is 10. We need to figure out what the y-intercept is. So we need to figure out what b is. So we do 2 equals 3 halves times 10 would be 15 plus b. And then we subtract 15 to both sides. And I get b is equal to negative 13. Okay. Now, the equation of our perpendicular bisector. We put our y, remember, leave y and x alone. The slope, which is 3 over 2. And the y-intercept, which is negative 13. And that is our final equation. Everything okay, Domo? Yes, it is. I think it's so awesome. Perpendicular bisectors are my friend. Okay, Domo, you need to get a life. Anyway, So let's take a look at the problem of your own to work out on your own. I want you to find the perpendicular bisector between 2 points, 4, 5, and 8, and 7. Okay, that's it for me today. If you have any questions, feel free to bug me in the comments. Otherwise, I will talk to you tomorrow. Later. Say bye, Domo. Domo says bye-bye. Dom, 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 dom.